This is the only cup that allows you to drink from an open container in 0G. But how does it work, and why do we need a special shape to drink without gravity? In order to drink from a cup, we rely on the fact that gravity is always pulling things down. So if we want to take a drink, we just have to tip the cup and the liquid pours into our mouth. We can drain the whole cup into our mouth just by tipping the cup more and more. But what if there were no gravity? Well, if there's no gravity, that means that there's no down or up. So when you tilt the cup, nothing happens. The water doesn't flow into your mouth. This is the problem of astronauts on the International Space Station. Usually on the ISS, because of the no gravity problem, astronauts drink from a bag with a straw. This works, but drinking from a straw gets old after a while. It's a different experience to drink a sip through a straw versus a cup. When we suck it through the straw, we don't get the smell of the drink next to our nose, so we miss out on some of the flavor. So how does this new space cup work? Well, it relies on the surface tension and cohesion of the liquid to the cup walls. Normally, in order to pull the liquid up, the cracks or holes need to be very small. For example, a paper towel works because of tiny little spaces in between the fibers. And in this capillary tube here, you can see how high the liquid rests naturally depending on the tube size. But if you aren't fighting against gravity, you don't need a tiny crack or a hole. You just need a slightly pointy section. So since this side of the cup has this sharp crevice, the liquid will naturally climb up the crack. But notice it isn't doing it now. That's because it has to fight against gravity right now. If we take the gravity force away, then we should be able to see the water climb up the crack. So how do we turn off gravity? Well, we do it the same way the ISS does. We just drop it. When something is in free fall, the gravity force drops to 0. That's literally why the ISS doesn't feel gravity, because they're in free fall as well. They're just moving really fast sideways, so they never hit the Earth. They just fall around it. So let's drop our cup and see if we can see the liquid climb it.
2, 3, drop.
Whoa, it worked. So in this case, the water actually climbed out of the cup. But if we had a longer time, then the surface tension of the water would have pulled it back into the cup. With dropping, we can only see it for a short time, but you can see the cup in action in this video here, with a real astronaut in space. It's so cool. So now we have cups that work in space. We're now ready for our interplanetary travel that we've been promised for the future.